Welcome to my class 12 Physics. Today we will discuss about the topic that is electrostatic potential due to electric dipole on the axial line. Here two points are there. One is electric dipole and another is the axial line. And before discussing this topic, let us recall about electric dipole and axial line, which we have studied in the chapter electric charge and field. Electric dipole means here we take two charges, one is minus q and another is plus q, and magnitude of the first charge, that is q. Magnitude of the second charge, that is also q. That means both the charges have same magnitude, but nature is opposite. One is negative, another is positive. And this is the distance between the two charges from A to B, and this distance we write that is twice of A. That means simply suppose we take two equal and opposite charges separated by distance, and that is known as the electric dipole. That is known as the electric dipole. Here you also write the definition of the electric dipole, that is electric dipole is a pair of equal and opposite point charges q and minus q separated by distance, that is twice of A. Clear? And here a dipole moment is there. What is the dipole moment? Dipole moment we write that is symbolically P. P is equal to magnitude of any charge multiplied by distance between the two charges. But dipole moment, or that is also known as the electric dipole moment, that is a vector quantity, and the direction of this electric dipole moment is always from the minus q to plus q. We write always from the minus q to plus q, so that finally we write dipole moment, that is P vector, is equal to q multiplied by twice of A. This is the magnitude. P cap, that is the direction. P cap, that is the direction of the electric dipole moment. P cap means that is from minus q to plus q. Clear? And here this is the center of the electric dipole. For this we write O, and from A to O, this distance we write A. From O to B, that distance is also A, so that A plus A, that is the twice of A. And here this is the line joining between the two charges, that is AB. This line is known as the axial line. Line joining between the two charges and also passing through the center is known as the axial line. And another line is there, that is passing through the center and perpendicular to the axial line. That line is known as the equatorial line. Clear? And now we will discuss about the point, that is electrostatic potential due to electric dipole on the axial line. So that first we draw the figure. This one is the figure. Here we take electric dipole, first pole, that is minus q, place start point A. Another pole is there, that is the plus q, place start point B. This point is the center of the electric dipole. We write that is O. We join from A to B. This distance we write that is the twice of A. And this is the direction of the electric dipole moment, that is minus q to plus q. And you draw the axial line. Axial line means line passing through the two poles. We extend in the forward direction, and this line is known as the axial line. And we take a point on the axial line. That point we write, suppose P. P point is the observation point. Here we will calculate electric potential at point P due to the dipole. Clear? Here we will calculate electric potential at point P, so that distance of point P from the center, always we write that is R. Center to observation point, always in physics we write that is R. Then A to O, this distance is r, this distance is a to O, this distance is a. That means from minus q charge up to the observation point, this distance we write r plus a. From minus q charge up to the observation point, this distance we write that is r plus a. Here we write that is r plus a. Similarly, this distance is a, distance between plus q charge and the observation point. Distance between plus q charge and the observation point is equal to r minus this one means a. So that distance between plus q and observation point is r minus a. Distance between the minus q and observation point, that is r plus a. Clear? Now, first at point P we will calculate electric potential due to the negative charges. You know the mathematical expression of the electric potential, that is V is equal to 1 divided by 4 pi epsilon 0. If charge is negative, we write minus q divided by, for distance we write here r. This is the mathematical expression, you know that. And you write for negative charges, we write that is V minus, or you also write here that is V minus is equal to 1 divided by 4 pi epsilon 0 q divided by, because charge is negative, we write that is the minus q divided by distance. Distance between the charge and the observation point, this distance is equal to r plus a. So that we write that is r plus a. This is the electric potential at the observation point due to the minus q charge. That is we write V minus. Similarly, we write this one V minus. Similarly, we will calculate electric potential at point P due to the plus q charge. For plus q charge, we write that is V plus. V plus is equal to 1 divided by 4 pi epsilon 0. Charge is plus q divided by distance. Distance between the charge and the observation point. You know this distance is equal to r minus a. So that in place of distance r, we write that is r minus a. This is the expression of electric potential. This one is the expression of the electric potential at the observation point due to plus q charges. We write this one, that is V plus. That means at the observation point, what is the total potential? You know electric potential is a scalar quantity. So that net potential at point P or resultant potential at point P is the sum of individual potential. That is V plus plus V minus. Clear? So that we write finally net potential V is equal to V plus plus V minus. And in place of V plus, we write its value. This is 1 by 4 pi epsilon 0 q divided by r minus a. And in place of V minus, we write that is minus of 1 by 4 pi epsilon 0 q divided by r plus a. And in this expression, q divided by 4 pi epsilon 0, q divided by 4 pi epsilon 0 is a common. So that we write the expression is equal to V is equal to, we take common, that is q divided by 4 pi epsilon 0, remaining is equal to 1 divided by r minus a minus 1 divided by r plus a. If we solve this one, then here r minus a is there, here r plus a is there, we multiply these two, so that is r plus a multiplied by r minus a. And in the upper part we write that is 1 multiplied by r plus a, that is r plus a, that is cross multiplication, that is 1 into r minus a, that is r minus a. If we open the bracket, this bracket, then we write that is r plus a minus r is there, this negative now becomes positive, so that we write plus a. And this one is r plus a into r minus a, you know the formula, that is a plus b multiplied by a minus b is equal to a square minus b square. So that we write that is r square minus a square. Clear? Then here R and R cancel with each other, only remaining is equal to, this is A plus A, we write that is twice of A. So that finally we write electric potential at the observation point, that is V is equal to, this is Q and this is twice of A. Twice of A, that is the distance between the two poles, and Q, that is the magnitude of the one charge. And you know the mathematical expression of the electric dipole moment, that is P is equal to twice A multiplied by Q. So that in place of twice A multiplied by Q, we write the symbol that is P. P is the electric dipole moment. And finally we write net electric potential at the observation point, V is equal to 1 divided by 4 pi epsilon 0 multiplied by P divided by R square minus A square. This is the final expression. This is the final expression of the electric potential at point P, due to the electric dipole. Now suppose P point is far away from the electric dipole. Then what happens? Suppose this point is the P point. From O to P, this distance we write that is R. This distance is equal to A. That means R is very greater than A. If R is greater than A, we write R square is very greater than A square. Then what happens? We write this one. If R square is very greater than A square, we neglect A square here. That means in place of A square, we put approximately or tends to 0. So that the expression becomes V is equal to 1 divided by 4 pi epsilon 0 P divided by R square. This is also known as the short dipole. That means for a short dipole means distance between the two poles is small as compared to the length between center of the dipole up to the observation point. So that we write this one is the one expression of the potential, and this one is a special case. So that your two expressions are there, and this is all about your electric potential due to electric dipole on the axial line. And in the next class, we will discuss about electric potential, same electric potential due to electric dipole on the equatorial line. Clear? And thank you.